Hi guys, this question is given in 2014 for 2 marks in set 4 for EC gate. So let's see the question. An n-type semiconductor having uniform doping is biased as shown in the figure. So this is a uniformly doped n-type semiconductor which is biased this way. So this side potential is negative, this side the potential is positive. Okay. If EC is the lowest energy level of the conduction band, okay, EV is the highest energy level of the valence band, and EF is the Fermi energy level, which one of the following represents the energy band diagram for the biased n-type semiconductor? It's very clear, it's a biased n-type semiconductor, because in general for a unbiased n-type semiconductor we know the energy band diagram. Unbiased, I'm writing here the unbiased one. This is EC, this is EV, and n-type semiconductor, EF will be somewhere here close to EC, okay, than EV. So this is EF in n-type semiconductor. Now how would we tell it is uniformly doped? By looking at the energy band diagram. It's based on the distance, I mean the difference between EC to EF. If it is constant throughout this with respect to distance x, if it is the difference between these two is constant throughout this with respect to x, then we can say it is uniformly doped. Okay, this is uniformly doped n-type semiconductor but unbiased at this point. Okay, let me write here so that this is unbiased. I'm talking about this figure. Okay, it is unbiased. Now if you apply negative potential on the left side and positive potential on the right side, what will happen to this energy band diagram? Okay, then that will be our answer from one of this. Okay, so if you apply negative potential on the left side, what will happen? And if I apply positive on the right side, see, positive potential means positive potential is higher potential compared to negative, because the potential is defined with respect to positive charges, not negative charges. But this energy band diagram as such is defined for electrons, with respect to electrons. We have seen that energy increasing is energy increasing for electrons, electron energy. Okay, so in that case, if negative potential on this side, which means negative potential is higher potential for electrons, positive potential is lower potential for electrons. Now in this case, this band diagram should tilt in such a way, when you give negative, which means the potential of electrons here is increasing, which means this band diagram should go up at this side, when positive, which means it should come down. So the energy band diagram should look like this. So EF and EV with respect to x. Okay, so this is how the energy band diagram should be. Now looking at this, we can say that the difference between EC to EF throughout the x is same, which means it is a uniformly doped semiconductor. Now there is slope for EC or EV, which means there is electric field in this semiconductor. Now we know one thing for sure, the slope of EC will tell you the electric field direction. Slope is negative, which means electric field is in this direction. So that actually matches with this semiconductor figure, right? That you applied a positive potential on this side, which means electric field is in this direction. That is exactly matching. Okay, so by this discussion we can say the answer here is option D. Okay.